Hello everyone, today I will give the introduction of my project. The topic is adaptive modulation and coding for wireless body area networks. About my project, I will divide them into 5 parts. The first part is background, and the second part is properties of WBN, and then I will give the introduction of IEEE standard for WBN. After the IEEE standard, I will introduce the channel model for WBN, and at the last, the conclusion will be provided. So now, from the background, owing to the advancement of wireless communication and microelectronics, the wireless body area networks have the significant basement and show the gradual development in the recent years, along with the development of the societies. The problem of rapidly diseases tend to more severe. In a common case, many people can be detected to suffer disease until it is too late. However, the medical expenses still stay at a high level, even seems like to rise continuously. These factors may reduce the quality of people's life. In this area, the wireless body area networks plays an important role so as to solve the issue. Since nodes which are put in or on the human body communicating with each other via the wireless channel, so it can be seen that the main challenge in this topic is guaranteed accuracy and the reliability of transmission. And to overcome the challenge, adaptive modulation and coding can be utilized to improve the performance of the arrow in WBANs. And next, the properties of WBN will be shown. The WBN is a technology of a wireless network based on the radio frequency, which allows the integration of the low-power, intelligent, micro-size, inversize or non-inversize, and lightweight wireless biosensors in, on, or around a human body in order to monitor body characteristics and the surrounding environment. These nodes transmit data in a small coverage, about up to 10 meters, and the WBN can be used in wide areas. I will introduce 4 sections. The first one is a medical application. Because of the world population is increasing sharply, which will overload the health care system. Meanwhile, aged population is rising. Moreover, a large amount of people dies from cancer, hypertension, diabetes, and many other diseases. Utilizing the WBN can monitor one's physical information such as body temperature, blood pressure, heart rate to prevent severe diseases. This method is able to reduce the expenditure of medical effectively. And the second one is military. WBN has a big potential in soldiers training. Putting the sensors on the soldiers, the data collected can be used to the commanders in order to give a scientific training plan. Furthermore, commanders easy to know the activities of the soldiers in the battlefield, so they able to give a quick and accurate command. Otherwise, WBN can also detect the body information of soldiers. If soldiers are injured, they can be found immediately and get the treatment. And the third one is the utilization in sports. The motion and physical parameters of the athlete can be monitored by WBN. It is a benefit for formulating a training plan and improving the performance. And the fourth one is in entertainments. Using WBN can improve traditional multimedia and gaming experiences, which control the game with hands, gesture, and mobile body motion. WBNs also can make the virtual world game, and people will go through a magic gaming experience. The WBN's communication architecture will be displayed. The WBN can be divided into 3 tiers. Tier 1, intro-WBN communication, and Tier 2, inter-WBN communication, and Tier 3, beyond WBN communication. In different tiers, it will have a different functionality. In Tier 1, it can monitor the body parameters and send them to personal servers such as BDA and the mobile phone. And in second tier, the personal server receives the information from the sensors, then store them temporarily and send them to a database. And in Tier 3, the different application can visit the database by using the internet. In the WBN is based on a lot of biosensors. The architecture of the biosensors can be divided into two types. The first one is star topology, and the second one is mesh topology. The star topology has a coordinator which seems as the center of this architecture. Other UU nodes send the data that collected from the human body to the coordinators directly via the WBN's channel, while the coordinators only have the responsibility for managing and transmitting data that have been collected by sensors to the outside networks. The star topology has the simple architecture, lower complexity of routing algorithm, less network delay, and easy to maintain. Meanwhile, it has the fastest speed of data collecting. Generally, this topology is better to use for the less sensors-based WBANs. The framework is shown as the fourth picture, and the mesh topology, each sensor node can transmit the data to the coordinator through the other sensor nodes. Any node can be seen as a router, which is able to not only send the data to other nodes, but also receive the data from others. In this architecture, the node consists of the sensors, battery, adapter, and a microcontroller. This topology has some obvious advantages. Firstly, simple to be extended. Secondly, easy to isolate the malfunction. And next is a comparison of two topologies. The difference between them are shown in the energy consumption, transmission delay, and interferences, and node failure. Next, I will introduce the attribute standard for WBN. This is the standard for short-range wireless communication inside, near, or on the human body. The standard is established to support for extremely low power quality of the service, and the data rates can be up to 10 megabytes. It uses the frequency bands which is existing and already have confirmed by national medical or administrative authorities. IEEE standard has defined 3 different physical layers: narrowband, ultra-wideband, and human body communication. The objective of IEEE standard is to define new physical and medium access control layers only for WBANs. One of the most important issues are selecting the physical layers frequency bands. The first one is narrowband physical layer specification. The picture shows the format for the PPDU in narrowband physical layer, and this is This specification is for ultra-wideband physical layer. And in human body communications, it is shows the specifications for it in physical layers. And the important thing in WBN is channel models. There are 3 types of nodes: implanted nodes, body surface nodes, external nodes. Implanted nodes is the nodes that enter the skin or embedded in the body tissues, and body surface nodes is on the skin, and external nodes is not in or on the human body. Is external from away the human body. And we can use some models to define the WBN channel. The first one is fading. The reflection, shadowing, body positive energy, absorption, diffraction, and multipass can make the transmission path experience the fading in the WBN. And the fading can be divided into 2 categories: small scale fading and large scale fading. In small scale fading, it will appear when a quick change of the amplitude and phase of the received signal in a small range because of the movement of the devices in a small area. However, the small scale fading could be removed by averaging the decay between each on-body antennas. The small scale fading also can be further divided into flat fading and frequency selective fading. Large scale fading compared with the small scale fading. This fading will occur when the change of the motion in a large area. The next one is path loss. In WBN, the path loss depends on the frequency and the distance. The path loss model in dB between the transmitter and the receiver can be described by the following formulas, where P path loss 0 is a path loss at a fixed distance 0. N is the exponent for path loss. D is the distance in a free path. And the shadowing is another channel model. The shadow means that it is a phenomenon that the change of the body motion and the environment surroundings the human body may cause the path loss can be different from the mean value related to a given distance. The following formula shows path loss equal to path loss in related to a fixed distance and plus the shadowing. And the fourth one is power delay profile. The power delay profile of the channel represents the average power of the signal. It appears due to the multipath reflection. And then the scenario of the channel model will be shown. There are 7 scenarios. It can be divided into 3 main parts. The first one is in body, and the second one is on body, within body surface nodes communicate to body surface nodes, and the third one is on body within body surface nodes to external nodes. This is a scenario for the WBN. And at the last, I will give the conclusion of my project. Wireless body area network play much more vital role in our daily life in the future. Reducing the BER is a big challenge in WBNs. The adaptive modulation and coding can improve the performance of the error. So, the research of adaptive modulation and coding is significant to make sure the possibility of the WBNs. My presentation end up here. Thank you.